Okay, great. So yeah, as obviously as mentioned, this is being recorded. Thanks for taking the time to join us today. The intention is to talk a little bit about some good practices for handling file permissions. It's really targeted towards your use of our HPC systems, but I think a lot of these these themes will be useful if you're trying to maintain file permissions on your Mac or your Linux laptop or whatever you have. Some differences on Windows. We won't get into that, but uh, I did. So the title of this session was Best Practices for Permissions and Data Sharing, but I attended a conference a few weeks ago, the U.S. Research Software Engineer Conference, which I highly recommend if you do consider yourself a research software engineer. There's a lot of good talks and discussion there. Well, one person made the point that like framing talks like this as a best practice is I think oftentimes, or they described oftentimes a little misleading because best practices change over time. And a lot of times they're also situational, and I think that that is true to a degree here. So yeah, allow me the editing there. We'll call this good practices. So just to give a little overview of what I want to talk about today, give you a bit of overview just in general of POSIX file permissions, the sort of the basic things that you probably do interact with on a fairly regular basis. And I'm sure some of this will be review, but hopefully, I want to make sure we're all on the same page when we get to some of the more extended, capabilities. Talk a little bit about NCARD defaults, and this is particularly HPC defaults, and why you might wish to change them. And that was sort of the motivation for giving this session to begin with. And then in terms of tooling to do that, I want to talk a bit about using ACLs or ACLs. We'll explain more what those are later on if you're not familiar. And then how you can use those to share data. And that should have said internal and external collaborators, but we'll certainly talk about both and actually more internal. And I just want to mention, like, if you're comfortable, feel free to just, hit that like hand raise button anytime in Zoom if you have a question or, you have a even just like an anecdote or anything like that that you'd like to share. It's totally welcome. We'll try to monitor the chat a little bit, but probably a little bit less than, the hand raising. Okay. So starting very basically, it's important to sort of understand and to have a good concept of what it means to be a user on a shared file system, in particular like a POSIX Linux system. So all users on any system, any Linux system, they have a username, a primary, or you can think of that as a default group, and then potentially a collection of secondary groups. And here's a few commands that you can use to query these values for yourself. If you're ever curious, obviously you probably know what your username is, but you can run this and find that out. Users are, your user is important because that is what gets tied to a file or a directory as the owner of that item on the file system. You also have a primary group. So you can see for me, it is the consulting services group team is my primary group. I've changed that. That would not be the default. We'll get into that a little bit later, but you can see what your default group is by using this command. And whenever you create a file, it's generally going to be assigned to whatever your primary group is. So that's why that's particularly important. And then if you want to see all of the groups that you are a member of, you can run this invocation of the ID command, or you can run groups. That's sort of a shorthand. And this will give you a full listing. Mine was long enough that I did the little ... because it was going to span off the screen, which is it's not necessarily good or bad. It's just, I guess I have a lot of options for what I'd want to set as my default group. And the range of the groups you're in is important to know because it sort of ties to your allocation. As you can see down here, pretty much. So anybody who's a user on our HPC systems is a member of the NCAR group. That's universal. And you'll typically have one group per active allocation. So you can see like I charge most of my jobs that I run to this SCSG0001 account. And as a result, or I guess sort of coincidentally, I am a member of that group. And that's typically how you think of like data holdings are going to be tied to, a group, just like your jobs are going to be tied to a project. So that's sort of how that maps. Yeah, Rachel, please.
I have two questions. One is, can we get these slides so I don't have to write all this down, not just the recording? Okay, sorry.
Yes.
My second question is that true for university people? I thought they were in a university group, not an NCAR group.
I believe they are also still part of the NCAR group.
Okay, awesome, great.
But I'll double check that just to make sure. I know Ben is in here as well. Maybe he has an idea, but I think every user is in the NCAR group, even though, yeah, to your point, like they might not be in an NCAR lab.
Okay.
All right, thanks for the question. And yeah, the slides will be available as soon as the recording is available. Okay, so extending that a little bit, we can use that information to think about the POSIX permissions model. This is, what you'll see when you interact with like the long form version of LS, for example. You'll get this nice organization of your standard POSIX permissions. And let's break this down a little bit. So I'm using colors, and I'm going to be consistent, hopefully, throughout this presentation. So I'm using this kind of blue here to denote user permissions, this greenish to denote the group permissions, and then this yellowish to denote other permissions. So basically, others is just anybody who is not that user or a member of the group. And then those are defined, the user and the group in particular, by these entries in your LS. So this is my home directory is obviously owned by me, and it's set to be assigned to the NCAR group, which again is sort of that generic wide open group. Let's put it that way. So all file system items, whether it's a file or a directory, have those three scopes. Each scope has three possible permissions. So you've got your read permission, your write permission, and your execute permission, or RWX. These do apply differently to files and directories, as you've probably seen. So, for a read permission, the file read is pretty simple. You can look at the contents of the file. For directories, it's a bit trickier. So if it only has read permissions, then you would be able to see the names of items within if you knew they were in there already. But you couldn't actually like traverse into that directory, so it's very limited. Meanwhile, write, you can modify the contents of a directory, of a file, or you can, manipulate objects within a directory. So write is fairly straightforward. And then execute, if you have a script or you have a program and you actually want to run it on the command line, you will need to give execute permissions. Now, let's say there is a bit of a gray area there even. So like if you have a Python script, if you wanted to just do /python to run that script, then it would need execute permissions. But if you run it as an argument to the Python interpreter, then it does not need execute permissions because you're using Python's binary as the executable instead of the script itself. So there's a bit of a gray area there, but in general, this allows you to run that thing as a command, that file. Now for a directory, again, the execute permissions allow you to access items within the directory. But in practice, really with directories, you're almost always going to need RX permissions combined for useful access, because that allows you to not only see the names of the items within, but it also allows you to, open them and really enter and traverse that directory. So those are almost always paired at the directory level. So if we look at my home directory, these are the permissions. Now you'll notice that it's not an X here on the others. That's a T. I'll get into that in a little bit. Those are some of the special permissions that you may know about. But in general, with this home directory, I can do all of the operations. I can read, I can modify the contents, and I can enter it. But others in my group, which again is pretty much everybody because it's the NCAR group, can read or enter, but they cannot modify. And same thing with others. Now, when you think about permissions, there are two different ways to represent them. So you've got symbolic notation, which is what we've looked at in the last slide, but there's also the octal or numeric notation. which you'll end up seeing a lot as both as output from commands and also in documentation. And it's really fairly simple to map between the two once you kind of wrap your head around and you use it for a little bit. So with the numeric permissions, basically you've got a number that can go from 0 to 7. And if it's 0, then basically there's nothing is allowed. If it's 4, then read is allowed. If there is, and then if you add 2 onto that, then write is allowed. And if you add 1 onto that, then execute is allowed. So your singular number there is an addition of these 3 potential additions. So for example, if I look at my home directory, the user permission, again, was everything. So read, write, X. So we add 4 to 1 and get 7. The group is only read, execute. So it's 4 plus 1 is 5. And then same thing here, the T you can think of as an X. And you can think about it like in the positional sense, right? Even though it's not an X, it's the third element. So that's going to be sort of the execute bit. And you're going to get a result of 5. So this whole representation here could also be represented as 755. And it's fairly easy to map those to and from. And actually, some commands will even let you specify an argument that'll say like, oh, give me symbolic notation or give me octal notation. Personally, I find them both useful. I think symbolic notation I use more often just because it's easier for me to split my intentions in terms of modifying permissions, which we'll talk about in a little bit. But this is also useful as as a shorthand, and especially if I'm running a lot of different operations at once where I'm setting permissions instead of modifying permissions, it can be nice. Okay, so thinking back to that T, many of you may know that is called the sticky bit. There are kind of 2 additional directory permissions that can be useful when you're like a user on a supercomputer. There's actually a third. There's the set UID, but that's kind of less useful on a system where you're not root. But in terms of the ones that can be useful, so we've got the set GID permission and then the sticky bit. I'll start with this one, even though I have it second, just because it's in my example. So when this is set on a directory, it ensures that the files within that directory can only be deleted by the directory owner, the file owner, or root. So that can be really useful if you've got like a directory that contains or that's accessible, even write accessible perhaps by a bunch of different people who are collaborators in a group, but you really want to make sure that like there aren't any unintentional deletions, no RM stars that could affect anybody else's data. So the sticky bit can be useful there because it really sort of restricts the really impactful changes that people can make on things that aren't directly of their own. Again, particularly when it comes to deletion. So my little joke here is it's like the Hotel California. You can go in, it's very hard to leave, and it's restricted on who can leave. So when you see the T, that's what that means. And we actually set that on a lot of like campaign storage directories, for example, the top level directory, a lot of them will have the sticky bit set because it's a nice kind of basic permission for, for that type of data, those type of data. And then the set GID, this is a bit less common, but you might still find it useful. So when you set this on a directory, it causes any items that are created in that directory to inherit the group of the directory rather than the creator's primary group. And that's overridable by some commands given arguments. But you can think about it like if I create a new file in this directory that has the set GID bit set, then it's going to get assigned to that same group that the directory belongs to instead of my primary groups, like which could be NCAR or CSG team or whatever. It's instead going to match that directory. So that can be nice again if you've got a lot of people collaborating in a single directory to make sure that the permissions are what you would expect versus like a hodgepodge of different primary groups. Okay, so in terms of modifying POSIX permissions, this is where we resort to the chmod command, chmod. And basically that's to change the mode of the directory. So that's where that name comes from. And basically you're setting the permissions on a file or directory, and you can do that recursively with this command. So for example, if I wanted to use like the octal notation here to change permissions on a file, here I'm setting that one single file to a 664 permission. And what that's doing is that's saying that all can read, because four, if it's four or higher, then all can read. Um, and then +2 for the user and the group. So the owner and the group can also write the file, but others cannot. Now that's of course going to depend on what group is assigned to that file, and we'll talk about changing groups. But that's setting that permission. So it's really just like kind of clobbering the existing permissions that were on that file. Now, if you use the symbolic notation, that also gives you the capability of modifying a subset of the classes. So instead of like clobbering all of the classes like we are here with the 664, we could say, okay, for the user and the group, whatever the permissions were before, let's add, read, and execute. And here I'm doing this recursively with the -R on a directory. So that directory plus all of its subdirectories and files contained within will have read and execute permissions added for the user and the group, whether they were there before or not. Now, one nice thing as well with the symbolic notation is that it adds this X modifier. And that is what I use more often for recursive operations than the lowercase x. So if you do a lowercase x, it's going to add execute permissions to everything. Whereas if you use the uppercase X, it's only going to add those execute permissions to directories, subdirectories, and also files that already have some execute permissions already on them. So like if it had a user execute, then this operation would also add a group execute if it was missing. And it will all add it to all directories, so you get that nice RX. But if you have like a file that should not be executable, like it's a data file, right, not a script, then it's not going to add execute when you use this X versus the lowercase x. So that's a really handy thing that I have I found super useful. You can also use, when you're doing the symbolic notation, you can use A, which is of course not our user group other, but it's for all. So that's a nice shorthand if you want to apply a modification to all three different types of access. Okay, so another thing with just standard permissions is this concept of a mask. Permissions masks come into play in a few different areas, but I think the place people most commonly will see it is with the umask setting. So if you haven't seen this before, what it does is it acts as a filter. So it restricts what permissions a program can assign to a new file or a directory. So for example, if I set umask 027, that isn't saying that new files will have no user permissions, right for groups and all permissions for others. It's actually the exact inverse. It's what we're filtering out. So a user could have all permissions, read, write, execute with 0 here, because we're not filtering anything. With the group, we're basically filtering write, so we're not allowing a program to apply write permissions to a new file. And then for others, with this umask, we're not permitting any permissions. So this can be useful if you want to, in a broad way, set a general default for how programs will be able to apply permissions. Now, programs could be more restrictive than what you have set with the umask, but it does limit how open they can be with new permissions. Now, this umask setting doesn't apply to Chmod. So whenever you change the permissions manually, you're overriding what is set here. This is just a default. And one thing to note about umask, it's not a command where like you set it and then it exists forever. It's basically applies to the current shell session that you have running. So you would use this either situationally, or more likely, if you have a default that you like, you would apply this in like your bash RC, so that it would be set in every shell and subshell that you want to run. Or you could put it in your .pro file if you only want it to be in sort of your login shell. Okay, yeah, I thought this cartoon was kind of amusing. Basic, it can be very convenient just to set very permissive access, right? Especially if you're like highly matrixed and you're working on a ton of different projects, but some of them need the same data or the same scripts, and it's just like it can be a burden to share things in a very restrictive way. So maybe you just want to set Chmod 777, which, if you recall, is open access for everybody. But that has probably pretty obvious downsides. It's certainly not good for data security and data integrity. And then there are programs, and we'll get into this in a little bit, but that store really kind of sensitive information in your home directory. So, it's not to say that having wide open read, write, well, probably not right, but having wide open read execute permissions are bad, but it's situational. So before we get into like the specifics of that, I just want to also review very briefly our typical file spaces on the HPC and sort of what their POSIX permissions look like. So again, all spaces that are listed here are globally accessible. We're not considering things like a temp directory that's specific to a node. So these are all the globally accessible or GLADE spaces. They all use spinning disk storage, except for home, which does use lower latency flash storage. So there can be reasons to put things in your home that aren't purely like backups. You do get generally faster read write speeds on home, but it's limited. So there's trade-offs there. So everybody gets a home, a work, and a scratch. And these are the default quotas, and we'll change the scratch quota upon request. Scratch is obviously purged. Home is, as I mentioned, backed up through snapshots. And then some people, probably a lot of people, will have access to some sort of campaign storage location, whether it's either a lab specific storage location, like if you're in, say, EOL, for example, then you'd have access to Glade campaign EOL. Or, if you're working on a university project, ESCAS, and/or if you're working on a university project, then it may have a specific project-based allocation, which will have a limited lifespan, generally like it's like the length of the project, basically. So these are both allocated, and the quota varies. But the permissions also vary a little bit across this, not too much, but our default permissions as of right now on your 3 default spaces are 755. So this is, read, write, execute, read, execute, read, execute for these 3. And the default group on all of these is that NCAR group, which, as I mentioned, is a popular group. We throw really everybody into the NCAR group as far as I can recall. Now, in terms of these spaces, again, they are either lab or project specific. So the permissions in these lab spaces will vary. There's, we sort of create the top level of that, and then the inner workings of how the lab space is managed is done by data managers within the labs. So that will vary. But in general, like this is going to be sort of the top level permission on it. And then for the university project, it gets assigned 770. So others there shouldn't really be able to do anything in that directory unless unless the owner of that project decides to open it up. So yeah, that's sort of a summary of how these spaces look right now. And maybe you can already see some potential issues with the defaults. So we have a very permissive storage environment. Again, this default NCAR group, it includes pretty much everyone, and that effectively makes, if you apply group right on like your home directory, which do not do, but if you were to, and you didn't change that default group, then effectively everybody on the system would have write access to that space. It is effectively makes group right all right in a lot of situations. So that is inadvisable. Now, this leads to a couple of suggestions, good practices. The first would be to change your primary group to a project-specific primary group. So like, as I mentioned, my primary group is CSG team. It was the NCAR group when I started here, but I changed that fairly quickly. That had benefits in terms of like collaborating as well. But it's also just kind of a good thing to do from like a base level group permissions perspective. And then the second suggestion would be to modify the file and directory group membership, as needed. So, if I have like a project directory where I have some collaborators, but it's residing in my work directory, then I could change the group of that directory to be, specific to that group. And that gives them permissions, escalated permissions to do stuff in there, whatever I've set it to with Chmod or via my UMask. So this introduces this other command, this ch group or group, if you want to call it that. This also permits recursive operations, of course. And basically you choose the group and then you specify like a directory. So an important thing to note is only the file owner can change the group of a file or a directory, or root, of course. But that's generally, if you come to us with a request to change groups on something, we're going to tell you how to do it instead of doing it for you. Or if somebody else owns it, then it's important to get their consent, of course, as well. Also, for changing the group, I should mention that that's done on SAM, on the Systems Account Manager website. Some systems you may do this like in the terminal, but we have it all in a database that's web accessible. And it syncs up with the system I think fairly frequently now throughout the day. So if you make a change, it won't be instantaneous, but it'll be fairly fast. Okay, I mentioned the open home directories. Currently, the user directories, when they're created, they're set to 755 by default and the NCAR group. That permission level might make sense for work and Scratch, and I would argue for probably a lot of us, since we're doing open science, that does make sense in work and Scratch. But home directories contain additional things that you need to be aware of. So you may have passwords in there in like dot files, for example. You may have keys in there. So if you work with like S3 storage, that's typically in like a dot credentials file or in a dot AWS directory. So that's something to be aware of. You may not want to have that wide open. You probably don't. And there can also be logs with sensitive information. So even if you aren't necessarily like, putting this out there in files, you may have programs that are doing so via logs. So you want to be careful about the home directory in particular. So our suggestion would be to restrict the permissions on your home, either set it to be 700. So basically you're not allowing anybody to read it and enter it with, no execute basically, and no read write. Or set it to 750, assuming that you've changed your group to something besides NCAR. So maybe like your direct collaborators, you're not too concerned about them seeing stuff in there. That's your judgment call, of course. But if you have stuff like this, it's probably best practice to just close it off to others in general. And that doesn't mean that you can't, and I'll explain this later, you can open up access to specific things or to specific people. But this is sort of a general broad permissions that we would recommend. Now, this was sort of the motivation for this whole session. So we're considering, and I think it's fairly likely at this point, that we're going to change the default home permissions in the near future. And this will probably apply to like new users rather than retroactively changing old users' directories on you. We're hoping that you do it yourselves. But I think for new users coming in at some point, they're going to be set to more restrictive home directory permissions. Yeah, Jacob, please.
How does this, thanks. How does this work for soft links if you have soft links in your home directory to Scratch and whatnot?
Yeah, so in terms of soft links, a lot of those commands where you apply them, a soft link does not have it like a collection of permissions, but it will forward the permission settings that you put in place to the file that the soft link points to. Now that's conditional though, because a lot of these commands will have flags where you can change the behavior, right? You can either follow the soft link or you can not follow the soft link. I think the default is to follow, but I would have to double check that.
Okay,
Does that
thank
answer
you.
the question or was
Yeah.
there? Okay.
Perfect. Thank you.
So another recommendation would be to use permissions to protect your data. I mean, that's like, I guess an obvious recommendation, but just to be cognizant and be thinking about it. So, any files that you have that with group or others write permission is essentially at risk of just like, unintentional behavior or unintentional consequences, I guess. So, I haven't seen this recently, but like back in the Cheyenne days, there were a couple of times where we had like a user try to run RM recursive remove on Glade Scratch. And there was a logic to it, because if you have files in somebody else's Scratch directory, it still counts against your quota. And it can be difficult, given the tools available, to like find where those are if you haven't been keeping sort of mental or actual physical notes. So, the thinking was like, well, I'm just going to like clear out everything of mine on Scratch and it's only going to remove my stuff. But that's not true. So like, there were a few people that had all write access and lost data. There's not really anything that we can do to prevent that because it's an open file system. And it's really incumbent on the data owners to make sure that like the right permissions in particular are locked down to who needs them. So that's probably the most important thing to consider in terms of like your work in Scratch spaces. There's also some security weak points that also could allow something like this that's more malicious. Something we've been thinking about a lot recently are GitHub self-hosted runners. So this allows you to basically set up a GitHub Actions runner on any system that you have access to. There's really no strong restrictions on that. And just like any other system, you can set it up under your user account on like Derecho or Casper. But depending on how you set that up, that does allow for opportunities for sort of malicious actors to come in here and potentially try to erase data. So, hopefully we would catch that at some point if it's happening, but it is really kind of hard to monitor. And we work with people who are interested in doing this sort of regression testing to make sure that they're applying good practices on their end. But it's also important for file owners and data owners to exercise good practices on your end. So again, restricting write access especially. So yeah, the suggestion is only grant write permissions when there's a specific need, and be as selective as possible to whom you give access, write access. Okay, but there's limitations, obviously, of sharing data with these standard permissions. There's a lot of power with the standard POSIX permissions, but you can't, like, here are two scenarios that you wouldn't be able to accomplish with them. So let's say you want to share like a sensitive data set with a single collaborator. I don't even want to open up like this to a whole group. I just want to give access to these data to one person. You can't do that with standard POSIX permissions, but you can do it with these ACLs or access control lists, file ACLs in particular. Another scenario where ACLs would come in handy are if you wish to share a project directory with another group in addition to the main project group. Because if you remember, a file only has one group that it's assigned to. You can't assign it to like a list of groups, but you can use ACLs or ACLs to add additional named permissions. So if in either of these scenarios with our standard tools, you would need to basically open read execute access to all users. And that is, based on these scenarios, is probably not what you want to do. So how do you do that with ACLs? There's a lot here, but I think you'll see it breaks down pretty simply. So if you want to interact with file ACLs, there's really two commands that you're generally going to use. You're going to use get FACL and set FACL, so file ACL, so set and get. We'll look at get first, just because that sort of demonstrates what we're looking at here pretty nicely. So let's just focus on this top set here. So these access control lists, they basically allow you to augment the standard permissions with named entries. And that named entry can be any user on the system or any group on the system. If you run this get FACL command on, let's say that like this directory here, it's also going to show me my standard POSIX permissions as well. So this is kind of a nice command just to give you an overall summary of access to the file. So I can see that like the user, which is me, the owner, has read, write, execute. The group also has read, write, execute. So this is a fairly open thing that I've set here. But I've also added a named entry for this SSG group, which I have read, execute. Now this is kind of a funny situation. I actually didn't intend to do this. I should have looked over this slide more carefully. So ideally, like this group permissions would maybe just be nothing, right? But I would add a named entry here that would give read, execute permissions to this group of the system administrators who, you know, are pretty close colleagues here in consulting. So, you know, in an ideal situation, or in a situation with where this had no group access, the SSG group members would still have read, execute, whereas others would not have any. And there's a mask entry here. Again, this sort of dictates what can be allowed. So you can modify file masks using ACL commands, but I'm not going to get too far into that here, because that's, I think, more of a special use case. But basically here we're granting permissions to specific users or groups, or as I accidentally did here, restricting permissions. So in this case, SSG could not write, whereas everybody else could, which is kind of funny. Or I guess people in CSG could, to be fair. So maybe I don't want SSG to have write access, but I do want CSG to have write access, the consulting group. Now here, there's also with these ACLs a set of default entries. So this basically specifies what access each entity will have, an entity being like user, group, other, and named entries, for new files that are created and new directories that are created within this directory. So it is literally like a default permission. I can use this to basically impose that any new file that gets created in this directory is going to also have read, execute permissions for the systems group. So, you know, this is nice because I don't have to go back a bunch of times and reset these permissions if I add data or create new files in this directory. It's that default makes sure that that's set. Now, again, that can be overridden by some commands with flags, but that would be sort of the standard behavior you would expect. So that's getting the access control list entry, but obviously we want to be able to set it as well. So that's where this set FACL command comes in. So if I wanted to, for example, grant a collaborator with username friend, write permissions on the file, then I could do this set FACL. There's a -m, that means modify. So you can also just set the ACL entry, but here we're modifying it. So I'm saying user friend read write, basically granting this one particular user with the name friend read write, and I'm giving the path to the file. So then that'll show up in that get FACL entry next time I look at it. That one particular user will have read write access, but nobody else will, depending on the other permissions that are set. If I wanted to extend this to like members of a group, let's say like I had some colleagues in the NWS and I wanted them to be able to view the current directory contents and any future contents. So I would use this set FACL command again. I can use this recursively, just like some of the other commands we talked about. And again, I'm modifying. So I'm adding a named group entry here that has read, execute. I'm using the capital X again so that it only applies in situations that make sense for directories and for files that should be executable. And then I'm specifying it on the entire directory and everything that is recursively within that directory. But I'm going to do this again, and I'm also going to set the default ACL for group NWS read execute for this directory. So by setting both of these, not only do I modify what's in there now, but the default makes sure that that propagates to anything that is placed in that directory, or not placed, but anything that's created in that directory in the future. And then, you know, I would run a help on set FACL because there's many different ways that you can run this command. But another sort of basic fundamental operation you might want to do is if you do -B and you give the path to a file or a directory, then you're going to remove all of the extended ACLs on that directory, including the default settings if there are any. So that's kind of a way to like clean things up and reset it back to standard POSIX permissions. One thing to note about ACLs, so they aren't actually supported by all file systems, and I think that's why it's like that. You know, some commands don't treat them as something to consider by default. Now, all of the file systems that you'll interact with on our HPC systems, and a lot of modern file systems really, do support ACLs. So I think it's just something to be generally aware of. But you know, there are cases where they aren't supported. So one downside of using ACLs in general is that some of the common file manipulation tools will not preserve them by default. So for example, like if you run copy, by default, that copied file will not have the ACLs that were on the original file, unless you specify the -- preserve equals mode option, and then that's going to preserve those ACLs, and they'll propagate to the new file. It'll have the same access control list. Similar with rsync, if you specify -A or -- ACLs, then you'll get that propagated to the copy that you've basically created with rsync. And then with tar, there's also a -- ACLs. So the thing with tar is you'll need to specify this flag both during the creation of the tarball and the data extraction. If you don't specify it either, like, you know, if you only specify it in one of those steps, you'll lose the ACLs when you try to extract data out of the archive. So, you know, point being, like, ACLs are, you know, it's not hard to keep them around, but you do have to be kind of aware of some commands that will strip them by default. And if you use them, you know, without some of these flags, then that can happen. Now you could set up like a user alias to bake this flag into the command if you wanted. You know, that would be an option to sort of make that easier if you wanted to propagate them all the time. Okay, so a couple more suggestions for good data sharing practices. Don't forget about extended ACLs. So I think in a lot of situations, they can be your go-to method for expanding access to files and directories. You know, a lot of times I think it makes more sense than just sort of opening up the standard POSIX permissions, because it's probably going to open it up beyond what's really necessary. And especially in terms of write access, ACLs are super useful. Now, a couple of tips in terms of ACLs. So the ls command will tell you if files and directories have extended permissions applied to them, even though it doesn't really get into the details of what those are. If you see this plus, then that denotes that that some sort of named entries, name permissions entries, are applied to this file, and you need to run get ifacl to see those in full. But if you see that plus, then you know they're there. And as another tip, you can also use named entries to restrict access. This is less common, but there are some special cases. Like if let's say you and a few others all sign into the same sort of shared project account. We do have some projects that do that. You may want generally like a directory and the data in it to have pretty open permissions to that group. But maybe there are certain files where you actually want that shared account to not have write permission, for example. You could use ACLs to restrict that down at that user, for that particular user, but then have the rest of the group be able to write. So that might be a situation where like it increases the ability to like attribute changes to a particular person, or at least not allow anything destructive to happen under the shared account. But again, that's kind of an edge case, and I think it's less common. One other thing I wanted to mention, and I learned about this actually in the last year or two. So you can debug permissions with this command. It's NAMEI. This sort of does a walk of the file that you give, or the directory that you give, and looks at the permissions of every layer from there. And it also, you know, it'll obviously stop when the permission is when you no longer have permissions to traverse in down to that final level. This is something that like I sort of do manually anyway when I'm trying to figure out some weird permissions thing. But you know, this command really kind of simplifies the process for you. So basically all you would do is you would run the command with a -L. There's different options for different types of outputs, but I find this -L output to be really nice. And then you specify the file. So this can be useful, like if you have shared a file with someone, or they've shared a file with you, and they think that like you should be able to open it, but you can't. you could run this command on it and it'll give you hints and it'll give you clues as to, you know, at what step this is breaking down. Why can't you see in there? Again, you can figure this out manually with some just kind of manual traversing, but I think this command really kind of makes it very easy. And then, you know, if there's a permissions problem at like a high level, then at least you could share this output with like us and the consulting team, and we'd have a good place to start in terms of debugging that problem with you. Okay, so one quick word. I think we've talked a lot about how ACLs are useful for sharing data with people who are already on the system. A quick word about sharing data with external collaborators. Our primary recommendation for doing this is using Globus guest collections because this allows anonymous access to data on the file system via a Globus collection that you set up. So it's going to point to just particular files that you decide to include in the collection. And somebody doesn't need to have to like authenticate onto our file system. Now, obviously, setting read on something like this is pretty scary. So I took this screenshot from the Globus website, but I would personally not recommend checking that box pretty much ever, I think, for this capability, but they do have it. One thing to note, though, is that the permissions that you can set via the Globus interface on a guest collection, they're layered on top of the POSIX permissions. So that's important to remember. So like, let's say you did set this checkbox for write, and you know, maybe you did it accidentally, or maybe you just weren't thinking about the implications. If those files that are in the collection don't have write access on the file system that the collection points to, then you still, like, people still won't have write access to those files. They won't be able to delete them, for example. So basically, you can't grant access via Globus to permissions that you don't have on the file system already. So it's kind of a two-layer permissions model when you're working with these Globus collections. And finally, user permissions that you set on the system, basically, yeah, they're dictating the maximum access that you can specify, that you can grant to guests. So it's kind of two permissions models layered on top of each other for this Globus access. All right, that's pretty much all I had. I'm happy to take questions. It looks like maybe there were a few in the chat, and hopefully they got answered, but if not, we can work through them. But I did want to mention that, you know, obviously we're always around to contact if you need to get help with something. So like, you know, you can call during normal hours, you can submit a ticket. We also have the NCAR HPC user group Slack, and these are all clickable links in the slides. You can also send me an email if you have a specific question from today or feedback. I guess one example of like where you would need to submit a ticket. So there's like, we talked about the chmod and we talked about the change group commands, but there is also the change owner command, chown, that you can only run really as root. So like we run into this situation from time to time where like somebody has left the organization, but that the data that they had in their account, it needs access from somebody else. We could set that up via ACLs, but if that data really needs to persist, then we might, given consent from everybody involved, do a change owner of those data to somebody else. So that is one additional sort of permissions operation, but I didn't talk about it here just because it's not something that you can affect as like a standard user. I can't do it either, in fact, because I'm not one of the system administrators, but we can direct those requests and help you out in those situations. So yeah, that's all. Rachel, go ahead.
Was I first or Seth? I can just go. So, okay. So I guess I don't even know if you know this, but I have been annoying Sizzle because I'm really struggling with ACL things and I basically don't get an answer. And so I'm wondering like how I can actually get help. I have asked to schedule a meeting to say like, I think I've made a big mess of things and I'm very confused about what's happened because of ACL and changing permissions and changing defaults and why things are doing things. So I guess my real question to you is if someone needs a little bit more help than just submitting a ticket with one question, what's the best way to do that? Because this is complicated. There's a lot of assumptions from your side that we know as scientists understand a lot more about this than we do. And I just, I feel like I'm falling into this place with a lot of complex projects across university users. And my default now is to just make everything open to NCAR, but I now know that I really don't want to be doing that. And then also helping when you have a shared directory, making sure that the people who are writing into the shared directory maintain the same permissions that you do. You know, it's like this gets really confusing. And so anyway, basically, how can I get more help is my question.
Sure, yeah. So I couldn't tell from what you said if you had tried doing a virtual consultation with us.
I mean, I basically asked if that was, how do you do that? Is that a way, like I basically have
Oh,
a
okay.
ticket saying, we'll try to get you in touch with somebody, and then I keep pinging it and no one responds. And so I'm kind of like, what do we do? Yeah, what are the options for help?
Gotcha. Yeah, so
Yeah, two quick questions. If you could forward us the ticket directly, maybe
Okay.
through email to Brian or myself, we'll follow up on that specific question. I'll put a link in the chat about scheduling a virtual consulting
Yeah, but
appointment.
just even knowing
Very
virtual
straightforward.
consults are available would be really great. I feel like I should have known that and I didn't. So that's what I kind of need is a virtual consult with somebody.
That's
So
okay, unless you read the daily bulletin daily, some of those things get missed.
I
I
definitely don't.
understand.
Other people do. Anyway, okay, thank you so much because this has become a big, and also I think at some point it would be awesome to talk about updating your ACL wiki page because it goes from like the simplest example to the most complex example, and there's like all of this gray area, and it would be super great. And also some information about how to, I have run into this experience where you think you've given someone permissions, you've done what it says, and they just can't access it. So you're like, then it's getting stuck. So anyway, thank you so much. This is a great thing. So thank you for putting this together also, I just want to say.
yeah, well, thanks for the feedback. And like Ben said, so I appreciate you, sort of we indirectly got around to the virtual consulting. I should put the link to that on the slide. I'll do that in future presentations, but and maybe I'll edit that so that when Tasia puts the final slides on here, it has that link. Yeah, I think, that I think it's really conducive to sort of this virtual consults because like, you all know what access the data should probably have, and maybe we know more about the tools, but we can't make the executive decisions on how it looks. So yeah, I think let's get one of those conversations going, and like Ben
Thanks
said,
so much. That
we
is
can-
wonderful to know because it is. We know what we want. It's just how to make it do that correctly is harder than I want it to be.
yeah, it's definitely tricky just because you're dealing with two different interfaces, right? And there's multiple layers. So yeah, believe me, I've been there. Um, and I also I remember you said you kind of open up the read execute permissions on some data, and maybe that's not what you should be doing. I think it really depends on the data set. I'll just make that comment that for some data that are just really like open data sets, I think that's totally fine as long as it's not open write access. But it really does depend. Like if you have proprietary data from like an energy company, then maybe that's not what you want. So it is situational. Seth, please.
So yeah, so this is very helpful. I already know a lot of these things and I still learn stuff. Hooray. What happens if I have a directory with no read or execute permissions outside of me, and there's a subdirectory that does have read execute permissions, and I point somebody to the subdirectory? Can you have something visible that's inside something that's invisible?
So not if the permissions on the directory above it are nothing. That's going to block access.
Okay. Would it work if it was like read access or execute access, but not read access or something?
I think there is a permutation of that, I believe, that would let you drill down into the subdirectory. I would have to play with it. I don't know if Ben knows off the top of his head.
Okay. Because if that's possible, it makes the prospect of making your home directory unreadable to the outside world a lot more appealing of like, oh, well, I know I can open up something inside it,
Yeah. So I believe there is a permutation there, but I'd have to follow up with you to play around with it a little bit.
I mean, it's not an immediate need or anything, but if you figure it out, maybe update this presentation with that info.
Sure. Yeah. No, thanks for the suggestion. And I think that's also like, I mean, this is a different angle of that, but I think locking down the home directory, but then using ACLs to open it up when it makes sense is also useful. Now, granted, like that doesn't help in the situation where I imagine like, yeah, you've got like a dot file in your top level directory that you want hidden, but then there's some subdirectory in there that you want accessible. So I understand the scenario you're talking about, and I'll add that in here.
Okay, thanks.
Thanks, Seth.
And post to the, you know, news when you figure that out.
Yeah, will do.
I'll
Yeah.
answer a different question that you didn't ask in case it causes some. So I don't know about that one. We'll look into it. But for anyone who's ever had to slide their homework under the professor's door, the Unix equivalent of that is a write directory that you cannot read to. And so we had a weird case where somebody wanted their students to submit basically project output by writing it to a directory, but not being able to take it back out or copy stuff. Just throwing that out there.
Yeah, I think we have that same permission set for a couple of like logging directories where we have a command and we want to understand how users are running that command, but we don't necessarily want people also examining that just because it, you know, it's global to all users. So yeah, there's interesting use cases for that for sure. All right, any other questions or comments?
I feel like you should make this mandatory training on Workday for anyone who works on the supercomputer. Sorry, it's my aside comment on this.
It's above my pay
That's a
grade,
lot
but
of
I
people
like it.
about ACL commands that I think know things, and they're like, I just open it up. And I was like, what if you don't want to just open it up? So, yeah.
Yeah, we like people to figure that one out before data are deleted. What were you gonna say, Ben? Sorry.
I was gonna say, we do have some people in Sizzle that would be very happy to hear that, along with the thou shalt not run sudo and consume all the resources on login nodes. Other, you know, best practices, good practices.
All right, no. Sounds like there probably aren't any more questions right now, but definitely reach out to us, or, you know, if there's a specific question from today, or you have another suggestion for something that you think would be useful to have in the slide deck, I'm happy to add it. So just send me an email with some feedback. But yeah, in any case, thanks for everybody's attention and time and input. And yeah, just reach out if there's a specific situation that, you know, we can help out with. But otherwise, have a good rest of your day.